Bismillahirrahmanirrahim. Dear students, we are going to start new chapter today. The name of the chapter is circular motion. This is the first chapter of the A2 class. In this chapter, we are going to learn angular velocity, radian, centripetal acceleration, centripetal force, and many more. Let us first discuss these first few things. To explain circular motion, let us first draw a circle, an object which is moving clockwise. So anything moves in a circular motion, in a circular path with a constant speed will be called circular motion. Now think the object is rotating and producing angle theta at time t. Okay, the object is making angle theta at time t. So if the arc length and the radius are equal, the angle produced at the center will be called 1 radian. Okay, here in the diagram you can see the arc length and the radius are marked. So you need to learn the definition, memorize the definition of 1 radian. The angle produced by an arc at the center which is equal to radius is called 1 radian. I am repeating, the circular motion is when something rotates in a circle at a constant speed, then this motion is called circular motion. Okay, the first term of the circular motion is radian. 1 radian is the angle produced by the object at the center by an arc which is equal to radius. This is irrespective to size of radius. That means for any sized radius, any sized circle, this is true. So we can write the formula for theta radian as well. Theta radian will be equals to S by R, where S is arc length and R is radius. And this is a well-known formula. Whoever had additional maths in O level, they know that S equals to R theta. So we got a formula, first formula of this chapter, that is S equals to R theta. We are repeating, the object is making an angle theta at the time delta t. Okay, so if the angle produced by an arc which is equals to radius will be called 1 radian. Now we are going to explain angular velocity. Angular velocity is simple, very simple. This is just angle produced per unit time. So we are writing what is angular velocity. The symbol is W, small letter W, and it is pronounced as omega. So we are writing what is angular velocity. Angular velocity is angle produced at the center of a circle per unit time, or you can say angular displacement per unit time. So we can write omega equals to theta by delta t. As from the diagram we can see the angle theta is produced at the center at time delta t. So we can write the omega equals to theta by delta t. or theta by t. It doesn't matter. You may write delta t or t. Now we will write another form of this angular velocity. For one complete rotation, the total angle produced at the center is 2 pi. Here we are writing theta equals to 2 pi and t equals to capital letter T. As you know, one complete rotation means one period. Okay, the time taken for one complete revolution is called period. So we are rewriting the formula omega equals to 2 pi by t. For one complete rotation, theta will be 2 pi and t is period. So this is a new formula. And another form is f equals to 1 by t. We know frequency equals to 1 by period. So we can replace 1 by t by f. Omega equals to 2 pi f. So we already got 3 more formula. W equals to theta by t, omega equals to 2 pi by t, omega equals to 2 pi f. Okay. Hope you understood. Now we are moving to the next page and next topic. Let us write the chapter's name again. Circular motion. Now we are going to explain centripetal acceleration. The symbol is A, small letter A. To explain this, again we are drawing a circle and considering an object is moving around the circle. So when something rotates in a circular path, though the speed is constant, but the direction of the object is continuously changing, and that's why we say the velocity is changing. Here we are drawing two random position of the object and drawing the direction of this object at particular moment. Let us consider the first position is A, second position is B. So velocity is changing, we can see from the diagram easily. At position A, the velocity was Va, and at position B, the velocity is Vb. Similar way, in every point, the direction of the velocity changing. So from this diagram we can say there will be a change in velocity. Though the speed is not changing, but the direction of velocity is changing. That's why we can say there will be a change of velocity. And we know if there is a change in velocity, there must be a acceleration. Here we are drawing to find the change in velocity and to find the direction of change in velocity. To do so, we are extending the line VA and VB, and from the law of vector triangle, the delta B is the resultant velocity whose direction is given in the diagram. So if we consider the resultant velocity, shift it from here to point A or to point B, then it will be always towards the center. Okay, if you imagine, you can understand the change in velocity direction is always towards the center at any point. Okay, so the change in velocity is drawn along the radius at point A and at point B. Similarly, in any point in the circle, the change in velocity towards the center of the circle, and this is the direction of centripetal acceleration. And the formula for centripetal acceleration is A equals to V square by R. We don't need to learn the derivation of this formula. We just need to learn the formula. A equals to v square by r. V is the linear velocity and r is the radius. So that is the formula for centripetal acceleration. Now we are going to write centripetal force. As you know from the Newton's second law of motion, F equals to ma. We will be just replacing the value of a by b square by r. So F equals to mv square by r. Very simple. So this is the formula for centripetal force. F equals to mv square by r. And we know the direction of force and acceleration is always in the same direction. So centripetal force also act in the same direction. That means toward the center of the circle. Now you are writing the relation between linear velocity and angular velocity. V means linear velocity, omega means angular velocity. We should have discussed before, but no harm, we can discuss it here also. For one complete rotation, the total distance traveled is the value of circumference of the circle. Okay, so we are writing for one complete rotation, the total distance will be 2 pi r. Okay, and the total time is capital letter T. So the linear velocity will be total distance by time, that is 2 pi r by t. V equals to 2 pi r by t. Now you know 2 pi by t, this is what? It was angular velocity omega, the marked one. So we will replace this value by omega and we will get the new formula v equals to omega r. This is the relationship between linear velocity and angular velocity, v equals to omega r. Okay, now we will rewrite the formula of centripetal acceleration by replacing the value of b. A equals to omega r whole square by r. By cancelling one radius, we get new formula A equals to omega square r. Okay, so this formula will be needed when you will be given the value of angular velocity to calculate centripetal acceleration, and the previous formula is given when you will be given the linear velocity to calculate centripetal acceleration. Similarly, centripetal force also can be rewritten. As we know, the V equals to omega r. So the formula for F will be m omega square r. It was written omega square r. It will be omega square r square. So r cancelled. The new formula of centripetal force will be F equals to m omega square r. So as we have the relationship between linear velocity and angular velocity, v equals to omega r, so we have two form of centripetal acceleration and we have two form of centripetal force. F equals to mv square by r, F equals to m omega square r. Done. So let us review from the beginning. In the first page we learned radian, then angular velocity, angular displacement per unit time or angle produced per unit time, and w equals to theta by t, w equals to 2 pi by t, w equals to 2 pi f. Okay, then For one complete rotation, theta was 2 pi and time was capital letter T, which is known as time period. Okay, in second page we discussed centripetal acceleration. When something moves in a circular path, the direction of the object continuously changes, and that's why you can say the velocity changes. And as the velocity changed, there will be a acceleration. Okay, and this acceleration is known as centripetal acceleration. A equals to v square by r. Okay, and v has a relationship with omega. V equals to omega r. We found it by writing v equals to 2 pi r by t, 2 pi r by t, and replacing 2 pi by t by omega. So v equals to omega r. We found it. Okay, then by replacing v by omega r, we got another form of centripetal acceleration, a equals to omega square r. And as we know from Newton's second law of motion, F equals to ma. By replacing a, we found the centripetal force F equals to mv square by r. And also we found another form of centripetal force F equals to m omega square r. That's all for today. Thank you.